Hello and welcome! Today, we're diving into a fascinating technique called supercritical fluid chromatography, or SFC for short. You might have heard of other chromatography methods used to separate mixtures, like gas or liquid chromatography. Think of SFC as a powerful hybrid of the two, combining the best of both worlds to give scientists a unique and efficient tool. So, let's break down what it is and how it works in simple terms. First, to understand SFC, we need to know what a supercritical fluid is. Imagine you have a liquid in a sealed container. As you increase its temperature and pressure, you eventually reach a special combination called the critical point. At this point, the line that separates the liquid and gas phases disappears, and they merge into a single phase that's not quite a liquid and not quite a gas. This is a supercritical fluid. It has the amazing ability to dissolve things like a liquid, but it can flow with very low resistance, just like a gas. The most common supercritical fluid used in SFC is carbon dioxide because its critical point is easy to reach, and it's cheap, non-toxic, and environmentally friendly. Now, how does this work in chromatography? The basic idea of chromatography is to separate a sample mixture into its individual components. In SFC, we have a long, thin tube called a column, which is packed with a material called the stationary phase. Our mobile phase, the supercritical fluid, is pumped through this column. We inject our sample mixture into this flowing supercritical fluid. As the fluid carries the mixture through the column, the different components in the sample interact with the stationary phase. Some components stick to the stationary phase more strongly and therefore move slowly, while others interact weakly and are carried along much faster. This difference in speed causes the components to separate from each other. At the end of the column, a detector identifies each component as it comes out, creating a graph with peaks that tells us what was in our original mixture. There are several major advantages to using SFC. 1. It is incredibly fast. Because the supercritical fluid flows so easily, separations that might take 30 minutes with liquid chromatography can often be done in just 5 minutes with SFC. 2. It is very efficient. The unique properties of the fluid allow for sharper, cleaner peaks, which means a better and more accurate separation of complex mixtures. 3. SFC is considered a green chemistry technique. Using carbon dioxide as the main mobile phase drastically reduces the need for the toxic organic solvents used in other methods. After the analysis, the CO2 simply turns back into a gas, leaving almost no liquid waste behind. This versatility makes it perfect for many applications, especially in the pharmaceutical industry for purifying drugs and separating chiral molecules, which are mirror-image compounds. It's also used in the food industry, for things like decaffeinating coffee, and in environmental analysis. Thank you so much for watching. If you found this video helpful and learned something new, please give it a thumbs up and consider subscribing to the channel for more science content. Don't forget to hit the notification bell so you won't miss our next video. If you have any questions or topics you'd like us to cover, please let us know in the comments below. Your support helps us create more content like this.